When the European Space Agency's probe passed over the south pole of Mars, no one expected to see anything particularly remarkable. Yes, there is permafrost, thick ice caps, and a dead frozen desert. But the ESA instruments unexpectedly detected something strange. Beneath the surface, under kilometers of ice, they found a region reflecting radio waves almost the same way as Earth's subglacial lakes in Antarctica. It was a real shock. Such a response could only be produced by liquid water. But how is this possible on a planet where the average temperature drops below minus 100 degrees Fahrenheit and the surface pressure is 100 times lower than on Earth? The most intriguing part is that this signal was not a one-time occurrence. It repeated in different areas and even shifted slightly over time, as if something was moving there. Researchers tried to explain the phenomenon. The first hypothesis is underground water, so salty that it doesn't freeze even in extreme cold. The second is the presence of a geothermal source, slowly warming the ice from below. And the third, they preferred not to publicize. It was just too reminiscent of the beginning of a science fiction story. But it was precisely this discovery that became a turning point. What was thought to be impossible suddenly turned out to be reality. There could be water beneath the ice of Mars. And if there's water there, what else could there be? Unexpected data began to arrive from other areas of the planet, and one of them recorded an especially strange signal. This signal was detected by a rover in the region of the Arcadia Plain. While the devices continued their routine tasks, one of the antennas picked up a low-frequency pulse. The signal lasted only a few seconds, but its structure was so orderly that it was impossible to rule out a natural origin. At first, the engineers thought it was a malfunction. They checked and double-checked. No errors were found. Then similar reports began to come in from orbital satellites. Short bursts of electromagnetic activity began to appear in different regions of Mars. They were unlike those caused by thunderstorms, solar storms, or even human activity. They came from within. Someone called it the Martian heartbeat. Rhythmic, steady, repeating at equal intervals as if someone or something was knocking beneath the surface. These signals matched the coordinates of areas where temperature anomalies had previously been detected. On the maps, it looked like a network of points connected by invisible threads of underground infrastructure. Perhaps natural, perhaps not. Some scientists put forward a bold idea. What if this was the remnant of an ancient biosignal, or worse, an active one? While official agencies tried to calm the panic, independent researchers began to dig deeper and uncovered the most controversial theory of recent decades. It concerned an ancient ocean that once covered half the planet. Mars was once blue, not entirely of course, but according to the latest climate models. A real ocean stretched across its northern hemisphere. Its area would have exceeded that of the Atlantic Ocean. The depth, on average, about 2.5 miles. All of this was billions of years ago. The evidence accumulated gradually. Signs of erosion, dried up riverbeds, marine sediments, even shorelines visible from space. But the main breakthrough happened when scientists modeled what Mars would look like if it had an atmosphere capable of retaining liquid water. And it turned out to be shockingly similar to Earth. The main question is, where did all that water go? Did it evaporate? Did it escape into space along with the atmosphere? Or did it go underground? For a long time, the last theory was considered unlikely, until new data from radars and seismologists emerged. Beneath the northern plains, huge voids were discovered that could be relics of an ancient ocean bed. But that wasn't the main thing. Some areas, as shown by thermal images, still retain traces of heat. And that means there might be not only ice left there, but also liquid, possibly entire pockets of ancient water, isolated billions of years ago. If they really existed, it would be the perfect environment for primitive life, or for traces of it. But how did this water not completely evaporate? The answer was found deeper down. Under normal conditions, water on Mars should have disappeared within just a few million years. But in reality, its remnants are still being found, and not just as ice in craters or at the poles. We're talking about liquid water, flowing, active. As it turns out, Martian salt plays a crucial role. In some regions, so-called perchlorates have been discovered. Salts that not only lower the freezing point of water, but can also keep it in a liquid state under extreme conditions. This kind of solution can be compared to antifreeze. Moreover, during certain seasons, dark streaks are observed on the slopes of craters as if water is seeping out from beneath the surface. These traces are called surface flows, and although there is still debate about their nature, one fact remains: they appear regularly. This means that there are still mechanisms beneath the surface capable of bringing liquid upward. Perhaps these are seasonal thaws, perhaps remnants of underground reservoirs, or maybe geothermal processes about which we know almost nothing. But the most questions are raised by one specific area. Their satellite data showed a subsurface temperature that would be impossible without an internal energy source. In a region called Medusae fossae, something strange has been detected. Beneath a layer of soil at a depth of about 1 mile, thermal imagers have discovered an area with elevated temperatures. It is not related to solar heating, cannot be explained by geological faults, and looks as if someone has turned on a heater down below. Nearby, there is a zone, of geomagnetic instability. The instruments are reacting with sudden spikes, and the soil contains unusual combinations of minerals. All of this suggests that there is some kind of activity below. But what is causing it? Some suggest a dormant volcano, others a sealed reservoir of liquid where a chemical reaction is taking place. But there is also a third option, the most controversial one. Supporting this theory are the shape of the anomaly, its perfect symmetry, and the strange pulsations detected by radar. Symmetry in nature is rare, especially underground. The scientific community is at an impasse. If the hypothesis is confirmed, humanity may, for the first time in history, encounter a phenomenon proving that we are not the only ones capable of building underground. And it was in this very area that the search soon began. Their target was a mysterious region with a resounding name. Elysium Planitia, one of the most enigmatic areas on Mars. At first glance, it appears to be an ordinary Martian wasteland. But if you look deeper, literally beneath the surface, the picture changes dramatically. Satellite observations here detect not just thermal anomalies, but a whole series of hotspots arranged almost in a checkerboard pattern. Beneath them are voids that resemble either tunnels or chambers. When scientists began analyzing the soil composition, they found that this region has a high concentration of volcanic rocks, but they are too fresh by Martian standards. These formations are only a few million years old. For a planet that is over 4 billion years old, that's like yesterday. And there's more. The areas where temperature spikes were recorded coincided with places where gas emissions had been observed in the past. Not carbon dioxide, but methane. And methane, as we know, can be produced both by geological processes and as a result of biological activity. The combination of heat, underground cavities, gas emissions, and geologically young rocks makes Elysium an ideal candidate for a habitat of something living or once alive. But the most astonishing fact was that some of these cavity shapes repeat themselves too precisely, as if they were created not by nature, but by someone, with intent. Against this backdrop, one particular discovery in a meteorite that fell to Earth several decades ago attracted special attention. It originated from Mars, and its internal structure has given rise to numerous theories. Allen Hills 9804. That's the name of one of the most discussed meteorites in history. It was found in Antarctica, and the age of this stone block exceeds 16 million years. Most importantly, scientists have proven that it came from Mars. But that is not what stirred the scientific community. Inside, structures resembling fossilized microorganisms were found. Formally, there is nothing impossible about this. Similar forms are found on Earth. But the problem is that no known non-biological process could create such symmetrical, thread-like formations. Of course, skeptics argued that these were artifacts, the result of contamination or the impact event. But there were fewer and fewer arguments left. And although extraterrestrial life was never officially declared proven, the meteorite became a symbol. Perhaps at some point something really did live on Mars. Later, other fragments were found containing organic compounds, amino acids, and even traces of water. All of this is of Martian origin. If there was ever life on Mars, then by all laws of logic there should be some traces of it left somewhere. And perhaps not only in rocks, maybe it is still there, hidden, or waiting, preserved. There were fewer and fewer doubts left when instruments detected not only structural, but also chemical anomalies in the planet's atmosphere. Mars releases gases from time to time. This has been known for a long time. But the most interesting part begins when these gases start behaving in unexpected ways. One of these gases is methane. It is periodically detected in the atmosphere, and the strangest thing is that it appears in bursts and then disappears. On Earth, the main source of methane is life. Bacteria, swamps, and the intestinal microflora of animals. Of course, it can also appear as a result of volcanic activity, but on Mars the volcanoes have long been dormant, officially. Nevertheless, observations have recorded methane spikes precisely in those areas where thermal anomalies and voids were previously found. Coincidence or a hint? In addition to methane, traces of hydrogen sulfide and even ammonia have been found in the atmosphere. These substances are extremely unstable, especially in a rarefied atmosphere. They should quickly break down under the influence of solar radiation, yet they are still there, which means that someone or something is constantly producing them. This made researchers wonder, could there be a subterranean microbiological ecosystem on Mars that feeds on chemical energy? There are similar organisms on Earth, for example, in the vents of oceanic hydrothermal sources. This led to a logical question. If there are similar forms of life beneath Mars, where do they live? And the most obvious answer is in hidden water systems, such as subglacial lakes. It sounds incredible, but such things already exist on our planet, and in extremely harsh conditions at that. Lake Vostok in East Antarctica is one of the most extreme and isolated bodies of water on Earth. For millions of years, it was completely cut off from the outside world, hidden beneath more than 2 miles of ice. And yet, traces of life have been discovered in it. This was a sensation. After all, if life can exist in such conditions, at sub-zero temperatures and in complete isolation from sunlight, it means it could also exist in similar conditions on Mars. Martian subglacial structures are strikingly similar in size and conditions to Antarctic lakes. Only there it is much colder. But with Martian salt and internal heating, this scenario becomes not so far-fetched. If such ecosystems really do exist on the red planet, they could be autonomous. Bacteria and microorganisms could feed on chemical compounds, creating a unique food chain. They do not need light, air, or surface water. They get enough energy from within. This scenario is so realistic that drilling projects in these areas are already being discussed. But while engineers are making plans, researchers have turned their attention to another oddity, the sound, or more precisely, the vibrations coming from underground that have no logical explanation. At first glance, Mars is absolutely silent. No wind, no thunder, no rain. But the seismometers on the Mars rovers have detected something different. Weak vibrations regularly occur beneath the surface. They are not like earthquakes. Their rhythm is steady and the frequency is stable. And most intriguingly, the sources of these waves do not coincide with known faults. Such vibrations are usually recorded in areas where temperature and chemical anomalies have previously been found. And that can't be a coincidence. Some of the waves radiate outward, as if something underground is pulsing or moving. Moreover, the movement is not chaotic, but follows arc-shaped trajectories. This is characteristic either of liquid flows or of mechanisms. And if it's liquid, that means the underground water systems are active. But if these are mechanisms, then that's a completely different story. But before drawing any conclusions, it's worth taking a look at places that could serve as ideal points for underground water to reach the surface. And one of these places is craters that have unexpectedly become oases. Amid the endless Martian desert, where cold and darkness reign, some craters appear to be alive. Of course, not in the literal sense, but data from orbital spacecraft show that in certain impact craters, especially at equatorial latitudes, there are areas with increased moisture, traces of mineral salts, and even seasonal changes in surface color. Gale Crater became especially famous after the rover discovered ancient clays and deposits there that could only have formed in the presence of water. And we're not just talking about water in the distant past. Some of the traces point to possible episodes of liquid water at much later times, perhaps even within the last tens of thousands of years. But the most intriguing aspect is that craters can serve as natural heat reservoirs. After a meteorite impact, residual geothermal activity can persist beneath the surface. And if there are porous rocks and mineral salts in such a basin, it creates ideal conditions for trapping and accumulating moisture. Some craters also show signs of cryovolcanic activity, a phenomenon where not molten lava, but a brine solution or muddy mass is pushed to the surface. This could explain the strange salt deposits found on the surface. Such oases become top priority targets for future missions. After all, if we are to search for active underground life anywhere, it would be precisely where there is water, warmth, and protection from radiation. However, the most unusual place associated with underground water isn't even visible from the surface. Its signs can only be detected by the emissions and traces on the slopes, much like underground geysers. On Earth, hydrothermal vents are places where water heated by the planet's interior bursts to the surface. Life thrives around them. Even in complete darkness and toxic environments, microbes, worms, and crustaceans can be found. It is precisely here that scientists believe the first forms of life on our planet originated. As it turns out, Mars may also possess such systems. And although no one has seen hot water gushing from the depths of the red planet, there are indirect signs, minerals that form only during hydrothermal reactions, and gas emissions with a thermal signature. They appear in certain regions and then disappear, as if someone is opening and closing a valve. Some of these emissions are accompanied by seismic waves and even changes in the chemical composition of the air. This means that somewhere deep underground, reactions are taking place that produce heat and gas. Such conditions could support life. Moreover, if there really was tectonic activity on Mars in the past, then underground reservoirs could have been connected by a system of cracks and channels, something like a pipeline for liquid and heat. And such channels could have become a refuge for forms of life, hidden from sight and from time. But if hydrothermal systems exist, it means that at one time they were part of a broader aquatic ecosystem, possibly even a marshy one. This hypothesis was long considered exotic until data emerged that changed everything. The very idea sounds like something out of science fiction, swamps on Mars. But when planetary scientists began analyzing satellite images of certain regions, such as Argyre and Hellas, they discovered strange, almost chaotic structures, winding channels, closed contours, and areas resembling dried-up peat bogs. Particular attention was drawn to deposits of sulfates and clay minerals. These compounds are known to often form in standing or slow-moving water, the ideal conditions for swamps. But the main thing is the microstructure of the soil. It is porous, saturated with mineral moisture, and has a high carbonate content. This indicates that in ancient times, Mars may have had not only rivers and lakes, but also fully developed swampy areas. Moreover, some scientists believe that such zones could have persisted longer than previously thought, up to the first few 100 million years after the planet lost its magnetic field. Swamps, even ancient ones, are of tremendous interest. It is precisely in such environments on Earth that fossils, biological remains, and even traces of DNA are excellently preserved. This means that if life once thrived in Martian swamps, its traces could still remain to this day, hidden, preserved. However, water could only be retained under such conditions if there was stable cold. And on Mars, this was ensured by massive ice sheets in which the entire history of the planet could be recorded. Ice on Mars is not just frozen water. It is a natural archive capable of preserving information about the climate, chemistry, and possibly even life. And especially important is the so-called ice trap, or a zone where conditions prevent the evaporation and movement of matter. The south and north poles of Mars are covered by multi-kilometer thick layers of ice. According to scientists' calculations, entire reservoirs of ancient water may be sealed beneath them, along with microscopic forms of life. But it's not just the poles. In some craters, where sunlight doesn't reach even during the day, ice has been preserved for thousands of years, not just on the surface, but deep below. Its structure is porous, saturated with gas bubbles including methane and carbon dioxide. These bubbles are potential containers for microbiological traces. The most astonishing thing is that samples of such ice, even when analyzed from orbit, show signs of movement, as if internal processes are occurring within them, albeit incredibly slowly. If we ever manage to drill through such layers and extract samples, humanity will literally be able to look into the past of the red planet and perhaps discover that someone is still breathing in this icy prison. But the ice is only the outer shell. Beneath it, processes may be taking place that shape the atmosphere of Mars. And this leads to the next paradox. Despite the fact that Mars's atmosphere is thin and rarefied, it behaves in an extremely unpredictable way. Observations record strange pressure spikes, local vortices, thermal anomalies, and chemical changes. All of this does not fit into the classical models of a dead planet's atmosphere. Research shows that some of these phenomena may be explained by underground activity. If chemical reactions or gas emissions are occurring beneath the surface, they can temporarily alter local areas of the atmosphere, especially in regions where subsurface structures and thermal spots have previously been detected. The most intriguing aspect is the presence of unstable compounds in the atmosphere, such as methane and ammonia. Their lifespan is too short for them to persist for long. This means that they must be constantly replenished. Additionally, at certain times of the year, hot spots appear in the atmosphere where the temperature is higher than can be explained by solar heating, as if energy is coming from underground. All these facts suggest that there may be a hidden but active system beneath the surface of Mars. It interacts with the atmosphere, produces gases, and alters the pressure. Perhaps this is the breathing of the planet itself, or of something living within it. And this breath leads us deeper to the traces of ancient water frozen in stone holding its secrets. Water leaves a trace. Even if it disappears, it changes the rock, the structure, the chemistry of the surface. It is by these traces that scientists learn to read the planet's past, like the pages of an ancient manuscript. And the most reliable archive on Mars has become the water-related minerals, clays, sulfates, carbonates. All of them form only in the presence of water. Moreover, different types of water create different types of deposits. Fresh water produces some minerals, salty water others, and hot water yet another kind. By these inks, we can trace where and when streams flowed, lakes splashed, and geysers boiled on Mars. The most remarkable discoveries have been deposits of opal, a mineral that requires the slow saturation of silica in water. This lengthy process, impossible without a stable environment, is often associated with hydrothermal springs on Earth, which means that finding opal on Mars confirms the existence of warm, silica-rich water. Moreover, in some regions, so-called manganese coatings have been discovered. This rare type of mineralization forms with the involvement of microbes and, on Earth, is exclusively of biogenic origin. On Mars, this could either be a coincidence or a hint. Every gram of Martian rock becomes an invaluable source of information. Within it are frozen epochs, catastrophes, and possibly life. If traces of biology can be found in stone, then what if some forms have survived to this day? Some believe that signs of life exist, but we simply do not yet know how to look for them properly. And some go even further, suggesting much more unusual hypotheses, including mysterious observations that have long troubled both researchers and enthusiasts. Mars has long been the subject of fantasies and fears. First, there were myths about Martians, then the paranoia of the Cold War era. Later, there was a surge of interest sparked by new high-resolution images. But some of these images have become the source of real controversy. Photographs from orbital probes have captured strange structures on the surface, regular geometric shapes, symmetrical lines, supposed domes and tunnels. Most scientists explain this as a play of light and shadow, as well as the effects of erosion. However, a number of these objects continue to stir the imagination, especially the so-called face on Mars. But even more intrigue is sparked by observations from Earth. Some ufologists claim that NASA equipment has recorded not only signals from the surface, but also anomalies in the atmosphere, rapid movements, heat bursts, and disappearing objects. Undoubtedly, there is little evidence. Almost all the testimonies are vague. But the very fact that such observations have continued for decades suggests something else. Mars is an object of interest not only for humanity, but also for its imagination. And while some dismiss this data as fiction, others wonder maybe we're just not looking in the right place. After all, if there really were an intelligent form of life on Mars, or traces of it, it would most likely be located beneath the surface. And perhaps we've already found them, but are simply afraid to admit it for now. But what if these aren't just traces, but actual structures? Arguably one of the most speculative yet fascinating ideas is the possibility of artificial underground constructions existing on Mars. It might seem absurd, but a closer examination of certain anomalies raises far too many questions. Take, for example, the same voids in Elysium. Their shapes are repeated and their sizes are identical. Their spatial distribution is regular. Instruments detect symmetry and strange resonant responses, as if the space were engineered. Add to this the temperature spikes, gas emissions, and local magnetic anomalies. All of this doesn't fit into simple natural processes. It gives the impression that there is something more beneath the surface than just caves or voids. The scientific community remains cautious, but behind the scenes, projects for deep drilling are being discussed more and more often. Some are already in development. After all, if there really is something there, humanity needs to know. And it is precisely for this purpose that new missions are being created. The next step is technology capable of reaching places where no probe has ever gone before. And such missions are already planned. NASA and the European Space Agency have long been working on projects capable of peering into the depths of Mars. Until now, rovers have only explored the first few inches of the surface. The deepest drilling has reached only a few feet, insufficient to access the structures of interest. However, on the horizon are missions capable of drilling dozens of feet and eventually even hundreds. The latest technologies are being used: cryodrills, thermodrills, and pulsed installations. Their goal is to reach subsurface zones where, according to calculations, there may be water, and if we're lucky, something more. One such mission, Icebreaker, aims to penetrate potential subglacial reservoirs. Another, ExoMars, is already equipped with a drilling rig capable of collecting samples from depths of up to 6 feet. But the main hope lies in the collaboration between private and government agencies. SpaceX, Blue Origin, and other companies are proposing radical solutions, including drilling with equipment delivered from orbit. It is precisely these technologies that could become the key to humanity's greatest discovery, possibly the first encounter with a form of life different from that on Earth. And then a question will arise, one that still sounds like science fiction, but may soon become reality. When we look at the stars, we search for others. But perhaps we have already taken the first step in that direction. And not somewhere near Alpha Centauri, but right here, within the solar system. Mars, once an oasis with oceans and swamps, may still be inhabited even now. Perhaps not in the form we're used to, not with cities, ships, or radio signals, but with life nonetheless. Persistent, humble, underground life. Every discovery, from methane to ice traps, from traces of water to seismic tremors, fits together into a larger mosaic. And this mosaic tells us one thing: Mars is alive, or at the very least, not dead. If we find life on Mars, we will understand that life is not rare in the universe. And if we find not just bacteria but traces of intelligence, then we will have to reconsider everything we know about ourselves. But for now, we continue to listen, to drill, to explore, and to wait for the moment when the ice cracks and the mystery reveals its face.